In this video, we are going to be turning this basic Radix slider into this. And you'll see we have some cool micro interactions that we've added here. We have a little bit of grow on hover. And when you drag it past the bounds, we give a little bit of feedback with this kind of neat rubber band effect and even a little bit of icon bounce. And both of these are inspired by the iOS slider, which I actually just built another version of for my new Radix course, but I wanted to save these for YouTube. So I'm going to show you exactly how I pulled these off with Radix and Framer Motion. So let's come over here and look at our starting point. And this is a pretty simple Radix slider, which has just been styled with Tailwind. And we see all kind of the default behavior here. And to kick this off, let's start just by getting this icon to kind of move and track the mouse when we drag past the left side. And this left icon is right here. And the way we can get this to move is by turning this wrapper div into a motion div from Framer Motion. And motion gives us an X prop, and we can use this to set transform. We can see it's moving it 30 pixels to the right, but if we make it negative, we can see that we can use that to kind of move it to the left. Now to make this dynamic, let's go ahead and put it in a motion value. So we'll use motion value. We'll call this X. And we'll start this off at 0 and replace this with the variable. And now if we just set this to different values, we'll see that it works just like before. But now we can update this motion value programmatically in the pointer move handler when we're dragging the slider. So let's come to our slider root, and we will add an on pointer move prop, and we'll get the event, and the event has a client X property, which is going to be the coordinates, the X coordinates of the mouse cursor. So let's call x.set to update our motion value with the client X. And now you can see that's moving as soon as we mouse over, but we only want it to move when we're actually pressing down and dragging the slider. And we can wrap this in if e.buttons is greater than 0, then we'll go ahead and set this. And now if we refresh, we don't update that when we move it, but if I start dragging, we see that it moves. So this is a nice handy little property of the mouse event that is 0 if we're not pressing any of the buttons or greater than 0 if we are. But now our icon is tracking the mouse, but the position is a little bit off. So let's come down and console.log our e.clientx and see what's going on here. We'll refresh and pop open the log. And now we can see when we drag right here, we're at 90, which means our mouse cursor is 90 pixels from the left side of the screen. You can see when I go down here, it goes down to 0. And right there, our icon is actually in its initial spot. So we want to offset the client X from the left side of the slider, and that will give us kind of the change in pixels that we've dragged. So how do we get the left side of this slider, how many pixels it is from the screen? Well, if we look at the event, we'll also see that there's this current target property, and this is going to refer to this element right here. It's the element on which the callback was defined. So we can call getBounding client rect on this. And we can grab a property from this client rect. And if we look at these properties that it has here, we'll see that we have a left property. So if we go ahead and subtract the left from the actual mouse position, now we'll see when we're on the left side of the slider, we're at 0, then we start to go negative or we start to go positive. So this is exactly what we want. Let's go ahead and put this right here. And now with any luck, if we drag right here, the icon's back to its initial position. And then as we move left and right, the icon tracks the mouse. So pretty cool. We only want it to actually track the mouse when we're negative though. We don't want it to go over here. So let's go ahead and put this into a variable. We'll call it overflow. And if the overflow is negative, that's when we want to actually set X to it. So let's go ahead and save that. And give this a shot. So now when we drag over here, it doesn't move, but the icon follows the mouse to the left. So pretty neat. If I move fast, you'll actually see the icon can get stuck in this spot. And if we go ahead and log overflow, you'll see why. we'll see if I go here and we scroll up, the last event, the last time pointer move fired, the mouse position was at -6, and then it jumped to 7, and that's just because pointer move only fires so often. But we want to account for that. So basically, if it's less than 0, we want to set it to the overflow. But if we ever get back into positive territory, let's just go ahead and reset X to 0 and refresh. With any luck, no matter how fast we move, the icon always comes back. So pretty cool. We're off to a good start here. The next interaction we want is when we let go of the mouse cursor, this should jump back to the initial position. So this is on pointer move. Let's go ahead and add an on pointer up. And right here, we'll just say x.set back to 0. So let's refresh this. And when I let go, it jumps back to 0. But if you play with this, you'll actually see it's pretty easy to kind of mess this up right there. You'll see I moved over and let go pretty quick, and our icon got stuck, which means this callback never ran. And that's because on pointer up only fires if you release the pointer kind of on the element, or sometimes you release the pointer somewhere else and it doesn't bubble or capture. It's not part of the same tree. So there's actually another callback called on lost pointer capture. And this is going to fire whenever the pointer is first captured on this event, and then we release it even if we don't fire that pointer up event on the actual slider. So I found this to be much more consistent, and now this is working great, except we don't want it to jump back. We want it to animate. So the cool thing about these motion values is that we can animate them. So instead of calling set 0, we can bring in the animate function from Framer Motion, and this takes in a motion value and then the new number we want to animate to. So let's try that out and then let go. And look at this, pretty neat. I can just drag and we get this really cool animation back to the left side. And this function here takes all the normal transition options from Framer Motion. So we could say type spring, and we let go. We're going to get a little bounce, and we can customize that. Maybe make the bounce 0.5. See how this feels. Something like that feels pretty cool. Okay, so our icon's kind of doing the behavior, this little micro interaction that we want. Next, we want to actually grow the bar so that it follows the mouse as well. And how might we do that? Well, let me just make this 100% again, and I'm going to make this a little bit smaller. Let's make it extra small so we have a little bit more room to work with. And how might we grow this slider? Well, the track and the range here have this wrapping div. So let's turn this wrapping div into a motion.div. And we can set the scale X property, which starts out as 1. But if we make it 1.1 or 1.2, we'll see that the bar is increasing the width here. So this is nice, except that it's increasing kind of in both directions, right? And that's because of the transform origin. That's kind of the anchor point for transform properties. But we can change that transform origin. Let's put this back to 1.2 with the transform origin property. And if we put this to the right, now everything is growing here towards the left. So this is kind of like the anchor point. If we actually look in the inspector here and we find our div, which is right here, you can see this is what Framer Motion is actually animating. And now if I increase or decrease this scale X, because the transform origin is kind of pinned to the right, it's just going to grow in that leftward direction. So pretty cool. This is exactly what we want. But there's one problem here, and that is that the scale is only possible to define in units of percentage. So 1 is 100%, and 1.1 is 110%. But our movement of our mouse is in pixels, and that's how we've moved our icon as well. So how do we know what percentage 50 pixels translates into, let's say? Let's go ahead and refresh this. I'll put this back to 100%. And let's say that the user has dragged over by, I don't know, 20 pixels. If we refresh that, we see the icon is now over by 20 pixels. And now if we come back down to our scale X, it looks like something like 110%. But how do we actually know what that actual number is? Well, if we put this back to 1, we'll see that our slider is 256 pixels. We can see that right here. And we've moved over by an additional 20 pixels right here. So 256 plus 20 is 276. 276 divided by the original width of 256 is 1.07. So if we can do this math, we should be able to figure out exactly what this value should be right here as a function of x. And the way we can make this a function is with use transform. So this is an awesome little method from Framer Motion. If we go ahead and import this, we can return 276 over 256. And there you go. We can see this matches up perfectly, but we want this to be a function of x. So this is 256 plus 20, but this should come from x. And how do we get that? Well, we can just say x.get and check this out. If we remember our order of operations here, make sure we add these before we divide by the width. Now when we refresh, it's a little shorter. That's because x is negative, so we need to subtract this. And now, if I drag this, check this out. The bar is sliding. Let's go ahead and reset the default back to 0. Refresh, and look at that. Pretty awesome. Let's let go. Pretty sweet, right? We're getting the animation of the bar because it is being expressed in terms of this X motion value. And because we're animating that X motion value and our scale X is a function of that, everything is working perfectly here. And so this is a great use case for these motion values from Framer Motion. You know, this is updating a lot. The animation updates a lot. You don't necessarily want to call react.rerender at 60 frames a second. When you have animation, this is why libraries like Framer Motion exist. These motion values are updating and animating the CSS properties outside of React's rendering cycle. So pretty neat. And the fact that they compose like this use transform syntax here is actually a newer syntax from Framer Motion, where we don't have to specify the dependencies, and we can just call x.get, and Framer Motion is going to take care of rerunning this transform every time x changes. So really nice DX here, and we can see that we get a little stretched bar. When we let go, it animates back, and this is looking pretty awesome. Okay, now that our left side is working, let's make the right side work. Right now, we are only updating x if our overflow is negative, but we're going to need to basically track the mouse position along this whole path and when it goes past the right bounds to get this to work. So how might we do this? Well, when working with these motion values, just to get a sense of how they're changing, it'd be nice if we got some information. We could kind of just debug this x. But if we come down here to where our volume React state is showing, let's just go ahead and add a new div right here and say x is x. And if we save this, we're going to see an error. It says objects are not valid as a React child. So again, this x motion value is an object. It's not a piece of React state. So we can't just render it like this, but there's a little trick if we were to wrap it in a new element and make this element, the wrapping element, a motion element. Now, Framer Motion will update the contents of this. So this is pretty cool. We can now kind of see exactly what our motion value is doing, even if our component is not re-rendering. And you'll see there's lots going on here. The decimals are kind of making it hard to read. So let's go ahead and use transform right here. And we can use x.get just like we did above, but this is going to give us a chance to go ahead and do some more transformation. Let's just say math.floor right here. And now we're going to see just the integers right here. So pretty neat. Use transform just returns a motion value as well. So we can also decorate this with something like tabular nums. And this way we're going to see x changing. We'll even see it animate. This is going to help us as we start to kind of add more functionality here. But let's go ahead and create another motion value, and we're going to try to track the overflow along the entire span of our slider. So I'm going to come up here and let's make a value called position. That'll start at 0. Let's also add it right here to our little debug area, position, and we'll change this to position. And now, if we come up here, let's go ahead and position.set to overflow outside of our conditional logic right here. And so now position is going to track our mouse kind of the whole way through. And you can see when we're dragging over here to the left, position and X are the same. It's only when we get here that X is 0. So if we could figure out how to express X as a function of position, then we should be able to do the same thing for the right and have both of those be derived from this new position variable. Except there's one problem. If we drag over here and let go, we see that we animate X and position doesn't change. So X is not really derived from position completely, right? Right here it's tracking it, but if I let go, position is -52 and X is 0. If I let go right here, position is -15 and X is 0. So X is not purely derived from position, but it is a function of changes to position. And Framer Motion has this awesome hook that's going to let us update X in response to changes in position. And this is called use motion value event. So this takes in a motion value, say position, and an event, say change, and it yields out the latest value. So let's just console.log latest, save that. And as we drag, we're going to see that that callback is firing every time position changes. So now instead of updating X down here, let's grab this logic and bring it up to our motion value event. And instead of overflow, we're just going to use latest. And if we refresh, we'll see that X is tracking position over here, but it stops tracking it over here because we just set it to 0. So this is all still working. But if I let go, we can still animate X independent. And I'm just going to comment out this volume down here. We'll just comment out our React state for now, make this a little bit simpler to look at. But this is pretty awesome. These motion values are kind of the core primitive of Framer Motion, and having them as a separate value lets us update them on our own terms. And I find they're really useful when you need more control over things like this. Sometimes you want them to be derived from another motion value or a change in React state, but sometimes you just want to animate them in an event exactly like we do here using on lost pointer capture. So this is pretty cool. And we've kind of moved that left icon logic out of the pointer move. And so we should just be able to create a new motion value for the right and kind of do the same thing. So let's rename this to X left, and we'll duplicate this and call it X right. And what should the logic for X right be? Well, once the position is right here, we want this right icon to start following the mouse, right? And check this out. We're at 256, which is exactly the width of the bar. So let's come back to our callback and we'll add a new branch here. And we'll say else if latest is greater than 256. We'll just hard code that for now. We want to set X right. And if we do this and drag, well, we're not using it yet. Let's go ahead and add this to our little debugger so we can see. This is now X left. We'll duplicate this, X right, and use X right. And now X right is tracking position over here to the right. But we need to subtract that 256 so that it starts counting up from 0. So this should just be latest minus 256. And now this is giving us exactly what we want, basically the inverse here of X left. We can see it gets stuck as well. So let's make sure to reset it here to 0 in the else block. Now we go left, we go right. That seems to work. And let's actually use this. We'll do exactly the same thing. Grab this motion div that's around our left icon, and we'll do it for our right icon, except we'll use X right. And now if we click and drag, pretty cool. The icon is moving. If we let go, it's stuck. So let's come here and also animate X right when we let go. And pretty neat, looks good. And all we need to do now is make the bar stretch in the right direction as well. And how do we do that? Well, we know how to stretch the bar to the left. We should just be able to come here and invert this. So we'll just kind of do the opposite. Instead of using this, let's change this to X right. and change this to left. And we'll see that this is shrinking this because x right is a positive number. So actually we want to add this to get a bigger bar when we drag to the right. And with that, we have the bar tracking the icon, and when we let go, it also animates. So pretty awesome. I can see here this is kind of shifting around. Let's give this a fixed width just so it's a little less distracting. It's about 100 pixels. Maybe give this a width of 120 pixels. But now that we have the right side working, we know how to do the right, we know how to do the left. How do we switch which side gets the correct logic based on whether we're dragging over to the right or the left? Well, if we knew kind of which region we were in, we could just use a conditional, right? Why don't we add some React state and do exactly that? So I'm going to come up here and create some state called region. And region will start off as middle, but we'll give it 3 values, either left, middle, or right, something like that. And we know we're in the left when the position changes to be negative, right? So if the position here is negative, we're in the left. If it's greater than 256, we're in the right, and otherwise we're in the middle. So let's just set the region to left here, to right here, and to middle here. And let's come down here and just add another little tag, region. This is good old React state, so we don't need to use a motion element. And now we have kind of left, middle, and right. So we should be able to use that state in our transform right here. And say if the region is the left, we want to use this old code. Otherwise, we want to use that right code. And then we'll also say if the region is left, we want the original, right? This is kind of the opposite of the actual region because it's the anchor point. And if we change this to a question mark, let's refresh. Grows left, grows right. Pretty awesome. Just a bit of React state to kind of conditionally update the logic of these two things. But check this out. This is awesome. Everything seems to be working great. We can click and drag and come back. We can let go. And React state is great for this sort of thing. You know, we're using motion values for the position and the X left and X right because those are being updated a lot and we want to animate them. But React state is perfect for things that don't change a lot. And I just love seeing how easy it is to use React state with Framer motion. They all compose together very well. So let's close this console, refresh, and just take a look at what we have right now. We have 3 motion values, and X left is being used for our left icon and right for the right icon. But now we have this region state. So because we now know if we're in the left or the right, I think we can simplify these two back down to a single X motion value. So let's do that. Let's come here and get X as a new motion value. I'll add this to kind of our debugger area down here. And let's come here and we'll update X in both the left case and the right case, like this. And we'll reset it down to 0 here if we're in the middle. So now we see X kind of tracks the left, it tracks the right, and if we let go, we also want to animate it back down to 0. So we'll do that right here. But now we have X tracking both of these other motion values, but we also have a piece of state that we should be able to use to update it correctly. So here where we're using X left, let's just say if the region is left, we actually want to use X. Otherwise, we'll just keep it at 0. And now left is looking good. But if we go right, we see X is increasing, but that left icon is staying the same. So pretty neat. We can just add some conditional logic with some React state. Let's do the same thing down here. If the region is right, we'll use X. Otherwise, we'll use 0. And the animations still work because nothing else has changed. And we're still only using X. We're updating it here in the value event. But this looks really good. Let's go ahead and delete X left, X right, right here, and right here. We'll delete it up there. We don't need to animate it anymore. And this means right here, we should just be able to replace both of these with X. And we'll go ahead and remove them down here from our debugger. So delete those. And now, look at that. The stretching works, the dragging works. We're kind of simplifying down everything to, the root state, what is actually needed to guide the animations and the following of the mouse cursor. Well, we just need to know if we're dragging and if we're off to the left or the right and by how many pixels. So this is kind of a nice little simplification here. Only need one X motion value, and it simplifies this as well as these two right here. So let's keep going and refactor away some of these magic numbers. Basically, we see here 256 we saw was the width of this bar. And this 256 shows up here, and we're also using it right here. And that means if we were to change this maybe back to small, make it bigger, if I were to drag this, we can see our slider is stretching too much, and it starts moving too soon over here. So we definitely have some hard-coded numbers here. Where is this coming from? This is the width of the slider root of this element right here. So let's go ahead and add a ref so we can actually query this from the DOM. And we'll come up here and call useRef from React. And we're going to see some TypeScript errors here because we haven't given it any type information. What are we passing in? We can use the element ref helper from React. And what type of element are we giving it? Well, this is interesting. We're passing a ref to a slider root from Radix, so we don't know what that renders, but we can use type of slider.root, and it'll figure all that out. So now if we hover this, it is a ref object for a span element. We'll see one more TypeScript error here. Whenever we pass a ref into an element, we want to default it to null to let React know that's exactly what we're going to do. And now we see no TypeScript errors. We have a ref, which means 256 right here. We can grab this from ref.current, and we'll get the bounding client rect. And we need to make sure that ref.current is defined. So let's go ahead and wrap this in an if. And this is going to be fine because this whole thing only runs on the client anyways. So we're definitely going to have the ref being set by the time this code runs. This gives us the bounds. And now we can replace 256 with bounds.width. And if we come down here, we'll do exactly the same thing. So let's grab this code and we'll say if ref.current. Let's go ahead, grab the bounds, replace them here as well. And now with any luck, if we refresh, looks like our functionality is back. So pretty neat. We should be able to change the width now to whatever we want, and everything's going to work just fine. If we look at this code for our scale X here, this is the code that is stretching the bar. Let's go ahead and close the console. We'll see that it now looks very similar. Kind of both these conditionals look very similar. And it's just because we either need to add or subtract X. You know, if we're in the left, X is a negative number. If we're in the right, it's positive. But we also know if we're in the left or right because we have this region state. So let's make X kind of a pure magnitude so that it's always positive. And we just need to change latest in the left region here to negative latest. So now X is kind of representing the overflow, right? And it's a magnitude. We can see here the direction is wrong for these transforms, but let's come down to where we're actually using them. And this needs to be negative X now, right? So let's use transform to turn this into a function and make this negative X dot get. So that works great. And again, I love these transforms. You can just kind of change them into functions of motion values. All you need to do is add this dot get to get the actual value. And now the bar is shrinking, but we should just be able to add this in both cases. So we should be able to remove all of this. Simplifies it down a bit. Very nice. We're to the right, we're to the left. We can let go, we can drag. Everything works. Let's also rename this X, right? Because we called this X originally since we were setting the X property of kind of the wrapping div of this icon, but it's really the overflow, right? Our mouse position is here. The overflow starts increasing when we drag past the bounds. So let's rename this. I think this will be a little clearer to overflow. So now if the region is left, we use negative overflow on the X transform. That reads clear. But when we scale it, we're just adding the width to the overflow to get the correct scale. So I like that. I think that's a little bit clearer. And let's also just go ahead and update our debug helper down here. It's not X anymore, overflow. So now overflow is just the magnitude that we've dragged past. And one last thing is our pointer move callback. We're using this to set position, but we're kind of querying the current target's bounds here to get the left side of the bar, which is kind of the same thing we're doing right up here in our value event. So let's simplify this down. I think it'd be nice if this was a little bit dumber. It just kind of tracked the client X, and then we can do all of our kind of transform, our business logic of our interaction work up in the event handler. So let's change position to just be client X. And that's going to be the name of our motion value. And right here, we'll just set client X to e.clientX, right? So now, if we move this, and let's go ahead and update down here, client X. Now, this is just the actual position of the mouse when we're dragging. And let's go ahead and copy this kind of business logic up into our event handler. So right here, we're saying if latest is less than 0, we want to set this. But now we have the client X. So how do we know when we're in the left region here? Well, if the client X is less than the left side of the slider, that's how we know. So let's say that if the latest value of client X is less than bounds.left, now we should be in the left region here. And we are. So at least our region state is working, but we just need to fix this overflow. How do we calculate the overflow? It's just going to be the left side of the bounds minus the client X. So bounds.left minus client X. And look at that. Still working. How do we know if we're in the right region? We just want to know if our client X is past the right. So if the latest is past bounds.right. That's how we know. And then the overflow here is just going to be client X minus right. Client X minus bounds.right. Otherwise, we're in the middle. So now we've kind of just moved all of this old logic here, which was kind of done in 2 steps, into just this single callback. And this is nice. You know, on pointer move is just updating this motion value with client X. And we're interested in changes to client X using this use motion value event function. And we get the bounds of the slider. If the client X is less than the left side of the bounds, we're in the left region. Otherwise, if it's greater than the right side of the bounds, we're in the right region. Let's go ahead and actually destructure these, make this even a little bit cleaner. Otherwise, we're in the middle. And this is pretty clear. Pretty easy to read what we ended up with. I like the way it looks. So now everything is still working great. But our state variable is a little bit more clear. Oh, that should be overflow. And oh, I just saw a bug. If I refresh this and we let go, it works. But if I click it and move it, you'll see something happen. And this actually doesn't have to do with our refactor. It has to do with this call to animate right here. So we're kicking this off whenever we lose the pointer capture. That means even if I just click right here, this is actually going to be animating. Now we're not seeing anything because we're not using overflow from 0 to 0 in our UI, but it is animating. And so if I click and drag this, we kind of get some wonky behavior. So what do we want to do? Well, if the user starts dragging, we want to cancel any existing animations and just have everything immediately track the mouse, right? So overflow is being set right here, here, and here if we're actually dragging. But there's another method we can use instead of set called jump. And jump sets the state of the motion value, but it also stops any active animations, effects, and resets the velocity to 0. So if I save this and reset, we're going to see all of our behavior still works. But if I click this and we go, this is going to work just fine. So it kind of makes the whole thing more interruptible, which is always something good to consider when you kick off an animation imperatively as a result of an event firing like we're doing here in the capture event. So this is looking good. But one of the best parts of this effect is that there's actually some decay to how much we stretch the bar once we're past the bounds. And that really is what puts the rubber band in the rubber band effect, right? It needs to kind of stretch less than what we're dragging it by. So we kind of want to decay this overflow value a little bit. Now we could come here, let's take the left region and just divide this by say 2. And again, let's remember our order of operations. And this should basically make this move half as much as we're dragging the mouse. So that does add a little bit of decay. That's pretty neat. We can make this, more aggressive, maybe 3 or 5. And that's a sort of linear decay, which is fine. But a nicer effect, and what actually happens with rubber bands in the real world, is that they stretch more at the beginning and less the further you pull on them. So I'm going to bring in a little decay function here. This uses a sigmoid, which is something I learned about while making this demo. And a sigmoid function is pretty cool. It's basically a mathematical function that has something that looks like an S-curve. And you can see here, this is basically exactly what we're looking for. As x increases to 1, the f of x goes up by a lot. And as x increases from 1 to 2, it goes up by less and less. And it kind of approaches this number here as you approach infinity. So this is going to be exactly what we want. If we use decay, we see it takes in a value and a max. Let's come here and we'll get rid of this -5. Let's just put this in a variable called new overflow. And we'll just set that here. But instead of just setting it as the overflow, let's go ahead and decay this. Now we need a max, and this is in terms of pixels, so let's just pick 50 to start. And if we drag, check that out. Look at overflow right here. As I go left, it's increasing to 50, but it never quite gets there. And even if I drag way over here and let go, it stops. So this is pretty cool, and you'll see this again in a lot of kind of the elastic motions in something like iOS's animations and gestures. It just emulates more kind of real world physics, and I love it. It's just so cool. It feels a lot better than the right side, right? And you can play with this max to kind of adjust it to how much you want. So if we wanted a little bit more, we could do 75. That's pretty fun for this demo. So let's go ahead and do this for the right side as well. Go ahead and decay this by 75. And now we have this really nice rubber band effect. Looks great. Let's pull this out actually into the bottom, just so we see this decay being used once. So I'll go ahead and call this down here. Let's move new overflow. We'll declare it up here and we'll just set it right here. We'll get rid of this. And this is latest minus right. That's the new overflow. Just refactoring this so we only call decay once. And right here, it's just 0. New overflow is 0. And now everything should work just like before. Pretty awesome. Okay, what about that grow effect that we saw on hover? Let's come to our root div here of our slider. This is the div for the left icon. Here's the slider root. Let's go ahead and change this to a motion.div. And motion.divs have a pretty cool little gesture callback while hover that we can use to set the scale, let's say to 1.1. And that's pretty neat. It's kind of scaling everything up. Let's make this smaller. This is 320 pixels. Let's just make this like 260, something like that. Got a nice little bounce to it. But if we try this out, we'll see that some of our math is broken. And this is because we need to do some scale correction here for these children. So if I remove this delay and we just set this to the new overflow, we'll see the bar is still stretching perfectly with our mouse pointer. It's the icon position that's going too far. And that's because this is in terms of pixels right here. But 10 pixels scaled up by 50% isn't the same as 10 pixels at 100%. So this little convenience method here is neat, but we need to correct our transform in the X for the icon. So we need to actually use the current scale value right here. So instead of using this, we can just grab another motion value called scale, and that starts out at 1 for 100%. And here, instead of while hover, we'll use on hover start to animate the scale to 1.5, and we'll use on hover end to animate it back. And now we don't see anything because we're not using scale, but we can go ahead and set that in style. So now we've got our hover back, and we should be able to correct this by dividing it by scale.get. And now look at that, we fixed that icon movement. Let's do the same thing over here to the right, overflow divided by scale.get. Oh, we weren't actually using a transform here, so let's go ahead and use transform. Since now this is a function of these things, overflow.get divided by scale.get, or 0. And that looks just like the one up here. But now these are working. We can bring our decay back just like this. And everything should be lined up. 50% is a little bit big, so let's go maybe to just 10%, something like that, or 20%. But I think this is a cool example of how some of these higher level declarative APIs that come with Framer Motion, like while hover, really just decompose into motion values. And we just created a new motion value right here, and we chose to animate it on hover start and end. These are kind of convenient little hooks that Framer Motion's added to motion elements. But now you should be pretty familiar and comfortable with the fact that you can set or jump a motion value or animate it anywhere you want. And all of these kind of declarative APIs are just conveniences for common use cases for that. But anytime you need more control, feel free to just create a new motion value and animate it or set it however you like. But now we've got a little bit of hover here. This is pretty neat. Let's actually make the bar a little bit taller too. That's something else that Apple does. We'll come and find our height of our slider. It's right here, H1.5. Let's bring this down into style. 1.5 is 6 pixels. So we can make this 6. And maybe when we hover it, it should be 16, something like that. So let's make this use transform. This is a function of scale. And there's actually a cool syntax here that we can say scale goes from 1 to 1.2. And we want the height to go from 6 to 16. So let's save that. And now we're getting some height animation. We're also getting some layout shift here because we're changing the height. But let's go ahead and correct that with some negative margin. So we can say margin top, and let's grab this. When scale goes from 1 to 1.2, well, the height is going from 6 to 16. That's 10 pixels. So if we go from 0 to -5 on the top and the bottom, now we're not getting any layout shift. So this is pretty neat. Let's bring this back up a little bit in width, maybe 300. But that looks pretty awesome. Just some more transforms. Everything is working great here. And again, just some more conveniences that Framer Motion adds to make us more productive, but it really comes down to animating motion values. One more fun little detail with the scale here. When we stretch, let's actually make it shrink to kind of give that illusion that it is being squeezed. And so this will be the scale Y. This will be another transform. And when do we want this to happen? We want this to happen when we're overflowing. And overflow here, we know goes to 75 because of our decay function. That's kind of the max value that it can ever be right here. So let's say scale Y is going to be a function of overflow. And as overflow goes from 0 to 75, let's make scale Y go from 1, say, to 0.9. So cool. Maybe even 0.5. That's pretty dramatic, but kind of fun. And then we let go. Everything goes back smoothly. Let's actually make this parent div here where we scale that has the hover and scale. And let's get rid of the max width so that it kind of takes up the whole space. I'm going to get rid of this padding as well. And let's control this by adding some padding here. So let's say padding X is 20, something like that. And now we can just kind of see when I let go, it stays scaled if my mouse is kind of along this. And this is just nice to kind of see everything working. I hover this, we let go, the bar gets squeezed, but if my mouse is still kind of on this plane here, we stay scaled. But if I go over and let go, we get the scale and we get the shrinking and overflow all going back together. Framer Motion just handling this all beautifully for us. And since everything is using transforms, everything is in sync. Okay, so there's one last little piece of polish I want to add. If you remember from the beginning, when I click and drag this and we switch basically the region from middle to left, we start overflowing. I want this icon to bounce a little bit, and you'll see that if you play with the iOS slider on your iPhone. But how might we do that? Well, here is the div that wraps our icon. And Framer Motion has an animate prop that we can use to set the scale. So we can set it to 1 or to 2, and you'll see it gets big right there. But we can also set an array of keyframes. So something like 1 to 1 is going to give it a little bounce, maybe 1 to 1.4, something like that. And we can also customize the duration here. Let's give it a transition object, and we'll set the duration to 0.25 seconds. So if I comment this out, that's kind of a fun little bounce. But how do we get this to happen only if we're dragging it past the left side of the slider? Well, we have the region in React state. So we can say if the region is left, we want to run this keyframe animation. Otherwise, we'll just leave it at 1. Check that out. Getting a little bounce here, a little extra feedback that you've gone over the edge. Let's do exactly the same thing for our right icon. Again, super easy to do with React State, except we need to make sure the region is right here. And now this is looking awesome. Let's go ahead and bring back our volume. Make this a little bit bigger. And check this out. We'll make this a little bit smaller. We are updating the React state here using Radix slider. All the original behavior from Radix is still included. I can even use my arrow keys to change this. Nothing has changed. If you know how to use Radix, we could add some focus styling here. We do that in the course actually. But we haven't disrupted all the cool stuff and behavior that Radix gives us. But now we have a completely custom interaction. It feels really awesome. And you could go so many ways with this. I mean, there's so many more ideas I'm sure you've gotten just by watching this, or how you could apply it to other interactions. But this is really cool. It's really smooth. It works great. I like this kind of interaction on iOS. It really stood out to me when they added it in the recent kind of major release, because it works especially well on touch screens. And even this, if you pull this demo up on your phone, it's going to work great. because it's a small control. You don't want to find the knob with your thumb on a small touch device, but when you interact with it, you get this growth, and then you can just drag it around, and it just feels really responsive and fun to play with. And I like that it's a clever, this rubber band technique is a clever way to give the user feedback when they've reached the end of a bar or the bottom or top of a page. You know, you kind of see it all over Apple's software. So hope you like that. Lots of cool stuff here. Just to do a quick overview of what we did, we really only added a few pieces of state for our animation right here, here, and here. And we have a ref. And other than that, we kind of sprinkle some motion divs in our tree, add some animations, and then this was the big one, using MotionValue event to make sure that we can have some of our motion values kind of be derived from other motion values in some cases, but not in all cases. And that gave us the freedom here to kind of animate them when we release the pointer. So hope you enjoyed that. If you want to learn more about Radix and Framer Motion, and Tailwind, which are exactly what I just used to build this, I just released a course on Build UI. I'm really happy with it. We build 4 components, and they kind of start simple and get progressively more complicated, and adding, you know, complex interactions, rich interactions like this, fluid animations with Framer Motion that work on mobile. But I also teach how I think about building custom components with Radix, starting with a simple use case where they kind of control their own state, and then progressing to having them control other React state in your app, and then dropping down to things like event handlers to add your own custom interactions on top of the interactions that come to change the value here. So if you want to learn more about that course, check out buildui.com. Otherwise, leave a comment if you have any questions about what we just covered, or if you have a demo or technique you'd like to see me cover here on YouTube. Thanks for watching, and I'll see you in the next one.